We're going to take a look at some things in Go. The first one of those is what happens if you have a Go program that fails to allocate memory and you reference a nil pointer. And I can do this very easily with this tiny little program. I declare this map. I don't ever do make to allocate memory to it, and then I assign something to it. And when I go and run this, okay, it goes kaboom, and it tells me the line when it failed on. These used to be, the kabooms from Go used to be much, much longer, and I'm certain there's some configuration parameter where you can get where it was in every thread that it's running. But in the latest version of Go, if you are running the .15 version, that has been reduced to the critical line that you need to find, which is you look down through it, and yes, you find your path and your piece of Go code, and it tells you the line number. And it also tells you that you had an assignment to entry a nil map. So you fail to allocate memory for that. Now, the reason why I'm showing you that at this point is because most people's problems when they got to doing Merkle trees, this is the kind of results they got because they failed to allocate something, they failed to copy something, and this is what you're going to be looking at in terms of seeing some output from Go and where you need to go fix whatever it is. So that is that. The second thing is Go has Go routines running concurrently for input and output. So just using something like format printf, you're actually running Go routines. And these Go things are not synchronized. They are unsynchronized. So if you use a map, now there are things you can do with a map without doing this, like you read in some initialization in the main routine at the beginning, and then you only read from that initialization. You don't have to worry about synchronizing it because you never write back to your configuration. But for a lot of stuff, if you want to have some sort of a safe counter, then you need to use one of these muxes and lock it and unlock it. So here I've done a safe counter. It has a map in it that I'm going to initialize. So down here in the beginning, I say create me a safe counter. Okay, and you notice that the map gets initialized by make right there. So I create storage for that map. So we don't do what we did last time and just make it go boom. The second thing is in here it has a sync mutex, and that sync mutex is going to make it so that we can synchronize and lock this piece of storage so that we don't have multiple people writing to it. And you only want one Go routine making modifications. So here we lock it, we modify it, we unlock it. And here's a different way of doing that. Okay, where we lock it, we use defer to say when the routine exits, go and unlock this. So if I've got multiple return points, I can do it without ever forgetting a return point, and then I return something from the map. And I've just used a very simple lock here. There is read-write locks, there are more complicated ones, but basically in the main program, I go and I do this. I create one. I run 1,000 Go routines in this piece of code. You should try this on your machine. And it increments this key. These things are all running continuously. I sleep for 1 second, and then I print out the value. So if without the locks, if you took them out of here, you will find out that Go will detect that you're being bad, and it will almost immediately crash your program and tell you you've produced a bad result. And it will not run. But with the locks, everything synchronizes, it increments, all is good. So you have to use those for maps. There are other places where you want to use it in communication, but that's a start on concurrency controls in a language. And we run it, and guess what? It doesn't go boom, and it does print out 1,000 like you'd expect. But That's 1,000 concurrent things running at once in a piece of code, just like that. That's how easy it is to manipulate and do concurrency in Go. Now, the last thing I wanted to cover is this, which is just a walkthrough of the homework, the assignment 2. Up at the top, it says you need to replace this. That's because I can't compile with things I don't use, and since I haven't provided the code in here, I can't use these packages and actually include them in the code, so you need to take this one out and put these others in. Now, here is the function. There is test code in the assignment. So the function takes in a block that we're going to mine, which is a set of transactions, and it has this difficulty string. The difficulty string is how many leading zeros there are in the hash. Okay, and I know inside here it says 4, but you really want to match with the difficulty string. So inside here, okay, we're going to do the mining process, which means that we're going to do an infinite loop. So just 4 squiggle bracket and a closed squiggle bracket to make the for work. And I've provided you with a serialize for the block. And this is serialized specifically for doing the seal, so it doesn't serialize the whole block. It only serializes the pieces that we need in it to be able to do this hash. And so go find that in the code. It's in block. Its name is serialize for seal. Go see what it does and get some idea of how it works. And then you want to calculate the hash. And there is a hashing function called hash of. And it see what it returns. So find the hash code and do that. And then convert the hash into a string. In the example that I gave you before, I used printf, but in this case, actually call the hex encode to string. It's faster than calling printf. And convert that to a hex to get the leading digits. If you print this out, you are going to get a lot of lines in step 4 if you print out mining, but it's actually pretty useful to see how it goes through stuff. And some Windows systems, for some reason that I don't understand, don't support \r. It is some configuration. If you're doing this on Windows and it streams all sorts of things across the screen, you may want to comment out this print statement. But others do, and I haven't found the configuration. So \r says basically go back to the same beginning of the same line without advancing to a new line, whereas some Windows systems just want to advance to a new line. But other Linux and Mac will just go back to the same line, but it gives you an output of what it is that you're seeing. And I say here the first 4 characters are 0. You really want to do something that uses that difficulty string so that you can have less characters. But in any case, use a slice of this and compare to the difficulty. Really what you want here is len difficulty. And then see if you've met the criteria. And if you haven't, then you do your increment and you go back to the top of the loop and do it again. And that nonce is part of what gets serialized. So if you do this enough times, eventually you reach the point where you have done proof of work and you have found the criteria and it is working and you are there. There is test code. Your prod has to pass the test code. So do go test and it will run this.